This is the first lab report for charged tapes by Julian Perez. Before the experiment, two interactions were tested. The first being having two pieces of tape which have been statically charged and seeing if they attract or repel each other. My hypothesis was that they would repel each other as they would probably have the same sign and about equal charge, and that was confirmed from my observations as they repelled each other. The next interaction that was tested was with a negatively charged pen, which was done by taking a pen and rubbing it in my hair. From then, the tape was attracted to it, meaning that the tape had to either be neutral or positive, and since they two did repel each other, and it was also attracted, the tape was also attracted to neutral objects like a book, then it must have a non-zero net charge, meaning it must be positive. From this information, it can then be assumed that the net charge on the tape is positive, therefore it would be a lack of electrons that are removed from the tape as when it is statically charged. The purpose of this experiment was to determine the charge on one of the two pieces of tape using the knowledge of electric forces. The way this was produced was by taking one of the tapes, being tape B, and placing it on top of another piece of tape that is on a table, and with the finger rubbing it, and then taking it off and putting it onto two stacks of books. This was then repeated, this time with tape A, but following the same exact steps. Tape A was then placed below tape B and slowly moved up until tape B was noticeably moved out of its original position. Then the distance between tape A and tape B was measured. Now, since tape B does not move in this scenario once A is held at a position close enough to it, that means that the net force is also zero. And the distance that was measured between tape A and tape B at that point was found to be 0.9 centimeters, and since both tapes are about the same size, it can be assumed that the net charge on both of them is the same, which is given the value Q in the formula. The free body diagram of the scenario was drawn on the left, which shows tape A on the bottom being flat, and tape B, which has both its weight, which is equal to its mass times gravity, and an upwards electrical force as it is repelled by tape A. This is, however, assuming that the tape can be treated as a point, both of its mass being in one location and its charge. As mentioned before, the net force acting on tape B must be zero. Therefore, the electrical force acting on it must be equal to its weight, which is equal to mg. After moving around the variables using algebra, it can be derived that the charge on tape A is equal to the distance between them, the tape A and tape B, times the square root of its weight divided by 1 over 4 pi epsilon naught. When I performed the experiment, I found that the distance between tape A and tape B was 0.9 centimeters, which is 9 times 10 to the negative 3 meters, and plugging it in along with the other values, I found that the charge on tape B and tape A, either one, had to be 2.97 times 10 to the negative 9 coulombs. Since this charge comes from the removal of electrons, then the number of electrons can be calculated using the charge divided by the charge of one electron. From this, it was found that 1.85 times 10 to the 10 electrons were removed in the process from both tape A and tape B. Finally, the percent of atoms in the tape that an electron was removed from was calculated. This was first done by calculating the surface area of the tape. Then, by treating the atom as a perfect cube, the surface area of the atom was found to be 1 times 10 to the negative 20 meters squared. Then, you can calculate the number of atoms in the tape by dividing the surface area by the surface area of the atom, which then gave a total of 1 times 10 to the 17 atoms on the surface of the tape. From this and the previous number of electrons, it can be calculated that the ratio of atoms that gave up an electron is 1.85 times 10 to the negative 7. Although these questions were answered throughout the previous points, here's a slide containing some of the questions asked in the lab report. And this code was used to calculate the charge, which gave the same number as it did by hand. The code takes the distance and, if necessary, to change the tape length, and from there is able to calculate the mass and finally the charge using the same equation used before. To answer the video lab reports, if electrons had positive charge while protons had negative charge, nothing of the observations would actually change, as the sign is arbitrary. What matters is that one is a scalar in one direction while the other is in the other direction. It would not have changed any of the observations made. Finally, the more the tape is handled, the more the charge on it is neutralized, which decreases the accuracy of the experiment.